Today we are working on 3.3, and it only has 2 topics in there, but it's a little bit tricky. So if I had x minus 3 squared, and I multiplied that together, I would get x squared minus 3x minus 3x plus 9, and that becomes x squared minus 6x plus 9. Okay. Similarly, if I had x plus 4 squared, that would turn into x squared plus 8x plus 16. So whenever you have the same factor times itself, you end up with a quadratic that follows a certain pattern. We're a little distracted today. Here's the pattern. This number here is half as big as that number. So this number here is half as big as that number. Okay? And this number is the square of that number. So this number is the square of 4. So we call these perfect square trinomials. They're a perfect square because if one side of a square was x plus 4 and another side of a square was x plus 4, the area would be this. The height and the width are the same. Well, we can actually use that to our advantage. So if I had x squared plus 10x, what number would create a perfect square? Not 20, you're close. 25. How'd you get 25? So what would go in here? Well, the pattern says that this number is half as big as that number. So this would be a 5. Okay. And if this is a 5, what would go there? 25. What's the rule? You square it. So plus 25. Okay. What if I had x minus 12x? What would go there? Well, this would be x minus 6 squared because it's half, and 6 squared would be 36. That is called completing the square. So completing the square means we have a quadratic equation that we want to be a perfect square. In order for it to be a perfect square, I need to add a specific amount to the constant, and we figure that out by cutting the middle term in half and then squaring it. And completing the square has several uses. The use that we're going to use today, maybe, is, so here, what number would complete the square? So 14 divided by 2 is 7, and 7 squared would be 49. So here I want to know, where is this parabola? So if it looked like this, I know exactly how to graph that. That would be left 1, down 2, right? But this quadratic is in the wrong form. It's in standard form, and we want to switch it into vertex form. And the way you do that is by completing the square. So this is a little bit tricky. So that number needs to get moved out of the way. So x squared minus 6x, I'm going to leave a space for my complete the square number and just bump that 6 over to the other side. Uh-oh. You're not paying attention. So, what number goes inside here? X minus 3. So if x minus 3 goes in there, yes? What? Yes. Yes. Yeah. So here I cut -6 in half and I get -3. If this is -3, what number should go right there? 9. Now, every equation is balanced. You can think of it as like a scale where the left side and the right side weigh exactly the same amount. So we have taken our scale and we have added 9 pounds to the right side. Now we are unbalanced. So we have changed the equation. It no longer is in the same place. So how do we make this scale balance once again? So if I added 9 to the right, I could add 9 to the left, and that would be balanced. However, when you graph an equation, you don't want anything on the side that says y. So when I add 9 pounds here, another way to balance it out would be to subtract 9 pounds over there, and essentially I've added 0. I added 9 on one part, but I subtracted 9 in another part, and those are going to cancel out, and I end up with -3. Yeah, it's a little bit confusing. So we'll do a bunch of these. Now I can graph it. What does -3 do to the graph? Moves to the right 3. So 1, 2, 3. What does -3 on the outside do to the graph? Moves it down 3. And then because this number is a 1, it's just a regular parabola, over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And it would look like this. Okay, let's do another one. Let's say I had x squared plus 2x plus 3. I want to graph this. So I bump the 3 out of the way. X squared plus 2x, leave a space, plus 3. Okay. What goes in my factor? X plus 1. This number is always half as big as the middle term. Does everybody understand that? Rich, you're really not paying attention today, man. That's all right. It hurts your grade, not mine. So, if this is a 1, what number goes right here? And if I add 1 to that side of the equation, now I'm unbalanced. So I need to subtract 1 to bring the balance back. And now I get this. Where is this vertex? Not right. Left 1, up 2. So left 1, up 2. And what's the shape of this parabola? It's just normal shaped. So over 1, up 1, over 1, up 1. Over 2, up 4, over 2, up 4. Like that. Yes? So the stuff on the inside always goes in the opposite direction you would expect. So the stuff in here moves left and right, but it works backwards. And the stuff out here goes up and down, and it works the way you would expect it to work. So anytime you're doing a transformation, the stuff on the inside always goes in the opposite direction. The reason is it's sort of asking, where would the graph have to be to move it to the right one and land where a normal graph is? what a normal graph would land, which is kind of complicated, but that's just the way it works. So the inside works backwards, the outside works the normal way. Good question. All right. Let's say I had x squared minus 10x plus 8. So this would be x minus 5. Oh, I need to move the 8 over first. So x squared minus 10x, leave a space, plus 8. X minus 5 squared. This is going to be 25. Oh, let's make this an 18. And now I need to subtract 25 so that everything will equal out. So this becomes a negative 7. Where does this quadratic land? Good. Right 5, down 7. And it's a regular parabola, over 1, up 1, over 1, up 1. Over 2, up 4, over 2, up 4. Hey. Yeah, hang on just a second. Do you need to see another one? Yes, I would love it if you would work on it.